Number 11. Find the probability of rolling at least 1 4 when rolling 2 dice. So for this one's a little tricky because for this you're going to want to remember that chart that I drew in class where we had where I remember it was like all the different possibilities of I don't know if I'm going to make all 6 there. That's what 5. Let's throw in another 6 there. That's 1 2 3 4 5. It's 6 there. Of like all the different ways you could combine those those 2 dice, right, with all the different possibilities there are for numbers. And so if these are the 36 different possibilities, right, the 1 and the 1 makes a 2, the 1 and the 2 makes a 3. Hopefully you remember that. So in this case, we actually don't care about what the sums are. We just care about the numbers that are showing up on the 2 dies, right? So this is one of them and this is the other one. So if you think about it, that means there are like 6 outcomes, right, for out of the 36, 6 of them here have a 4 showing up. And then of all the 36 outcomes, then there's 6 here that also could show up, with it showing up on the other one. So in this case, I'm going to have the 2 probabilities, right? So in each case, it's going to be 6 out of 36. So I have this 6 over 36 plus another 6 over 36. But if you look at the chart here, you'll notice that there's this one time here where they overlap, right? So we could do it. It could be like the probability of 4 on die number 1, or so that should be an on, or 4 on die number 2, right? Is going to be equal to the probability of 4 on 1 plus the probability of 4 on dice number 2. But then we need to subtract out the probability that the 4 shows up on both. Right? And so how many times does that happen? Well, it only happens this one time here. So I'm going to subtract off that 1 over 36. So I would have 12, but then I subtract off that 1, so that gives me a probability of 11 over 36, which is going to be answer choice A. So like I said, that one was a bit more difficult, but something I'm confident you could think your way through. For number 12, a car approaching an intersection has a 0.1 probability of turning left and a 0.2 probability of turning right. They ask us what is the probability that the car will turn. So it sounds kind of weird, but really what they're saying is what's the probability that it will turn left or turn right? There's only ways you can turn. So in this case, it's going to be the probability of turning left plus the probability of turning right. And is there going to be any overlap here? Can we turn both left and right at the same time? No, we can't. So these 2 events are disjoint. So I'm just going to add up the 0.1 plus the 0.2 and get 0.3, which is going to be answer choice D. And then for 13, the letters A through P are written on cards and placed in a bag. Find the probability of choosing an E or choosing a vowel. So if we count out how many letters there are from A to P real quick, that will be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. I just did that off screen, sorry. So that's going to be a total of 16 letters there. Just count that out on my fingers. So the probability of getting an E or a vowel is going to be equal to the probability of getting an E or the probability of getting a vowel. Sorry, I'm going to add probability of getting a vowel. And is there any overlap there? Well, of course there is. E is a vowel. Right? So the probability of getting an E is 1 out of 16, plus the probability of getting a vowel. So this one is kind of, you gotta be careful because you might want to say 5 because there are 5 vowels in the alphabet, but there aren't 5 vowels in the actual bag, right? So we're only going up to P, so that means we're not including U. So there's actually only 4 that are possible outcomes there. in terms of getting vowels. And then we need to subtract off the 1e that is a vowel. So in the end, when you do that math, of course, 1 plus 4 minus 1 gives us just 4 over 16, which just gives us 1/4. So then it's going to be answer choice A. Alright, almost done. Of the 3,510 drivers surveyed, 1,950 were male and 103 were colorblind. Only 6 of the colorblind drivers were female. What is the probability that a driver was male or was colorblind? So we have the probability of, male or colorblind. That's going to be equal to the probability of the driver being male plus the probability that they're colorblind, minus out any overlap, which in this case there will be, male and colorblind. Alright, so the probability they're male is going to be 1,950 over 3,510. Colorblind is 103 over 3,510. And then this number, well, if 6 of them were female, then I'm going to subtract 6 from the 103, which gives me 97, which means 97 were male and colorblind. So I do some math here real quick on my calculator. I get, what were the numbers here? 1950 plus 103 minus 97. It's 1956. So 1956 over 3,510. Divide that real quick by 3,510. We get 0.557, which is going to be answer choice A. This is a good classic problem, 14, so you should definitely be able to do something like 14. I'll definitely show up on the quiz. Oh, cool, and then the last one. So this is like one of the problems that was on, I think it was 10.4 in the workbook, that in some of the classes we got to, and in some of the classes we didn't, depending on whether or not enough people in the class like actually tried it for the homework. So I'll go over it here fairly quickly. So in one day, 5 different customers bought earrings from the same jewelry store. The store offers 62 different styles. Find the probability that at least 2 customers bought the same style. So in this case, where they're asking us to find the probability that at least 2 did the same thing, this is where we're going to use the complement. And to find the probability that at least 2 different, we're actually going to do that by subtracting from 1 the probability that they are, sorry, that shouldn't be 2 different, that should be 2 the same, my fault. Find that they're all different, right? So the complement of at least 2 the same, the opposite of that is that not 2 of them are the same, which means that all of them are different. So the way we're going to do that then is to have 1 minus, so all the possible outcomes. So again, if there was 5 people that came in, they all had 62 to choose from, so that's going to be 62 times 62 times 62 times 62 times 62 one more time. So 62 to the 5th. And then in the numerator, if they're all different, that means for the first person they had 62 options, but then for the next person they only had 61, and then 60, and then 59, and then 58 to choose from. So that's going to be, so I'm going to plug it into my calculator here real quick. I'm going to do 62 math over option number 2, P5. That's the numerator. And then I'm going to divide that by 62 to the 5th power. So I get that. And then I want to do 1 minus that, so I'm going to do 1 minus the answer there. And I get 15, so it's going to be, what is that going to be? Yep, there it is, option number A. 15.24 after I round there. Cool. So that's it. And looking at how much time this took, that took about a little more than 20 minutes on my clock, but I also started off explaining things a little bit there, giving you the answer.